Hi, Rashid here. Today, I wanted to give an overview of how I'm looking at this course and what are the topics I have covered, what are the topics that I will cover in future. Today is August 14th, 2024. And as I teach more, as I get more experience in it, I'm tweaking things a little bit. So I'm going to do a regular review of how I plan to teach and what topics I plan to cover so that people watching those videos also see a higher level plan on what they expect from me so that they can connect the dots and understand my whole plan and also understand their own plan on how what are the things they're going to learn in future. So I thought let's do a different video today, and maybe in a month later I will do another video similar one, and maybe I'll tweak few things a little bit. But just wanted to give you an idea of what I'm thinking today. Okay, so I started with digital design. Okay, I have covered combinational circuits. I have covered sequential circuits, and I mentioned only the functionality of the logic design. I haven't touched on timing, propagation delays, and all those things. I'm just done with sequential, and next few videos I'm going to give you a primer or refresher of SystemVerilog. So this digital design, which is in the form of combinational and sequential circuits, we implement that in the industry using hardware description languages or HDLs. And this is also called this description, and these languages are Verilog, SystemVerilog, and VHDL. I'm going to pick SystemVerilog. And when we write this hardware in these languages, this is also termed as RTL in the industry. So whenever we say, hey, write RTL, that means somebody write digital design in using these hardware description languages. RTL stands for register transfer logic. Don't remember the history how they came up with this one, but you can think of it as, okay, there we have registers here and we are transferring combinational logic onto the sequential logic. So once we have RTL understanding and how we're going to implement, I will give different examples from here and here. The next thing is in IC design, the core thing, the fundamental unit is transistor and the connectivity of transistors among each other. So this is where I think it's really important. Once we have look at a higher level, we look at the core transistor, understand how it works, understand how we connect different transistors and make up larger circuits which are combinational and sequential. Because once you know the core thing that we are really changing with the transistor, you will make a good idea of it. You'll make better circuits in future. You will understand what are the parameters that you need to change in order to improve timing, power, and area, or power performance and area, PPA. And once you understand those one, we will get into physical design. So once we have RTL, yeah, somebody needs to validate RTL thoroughly, but in parallel with RTL validation, what we start is we start converting RTL into transistors. And in large designs with RTL, with billions of transistors, we can't do that with hand. So we use physical design, implementation, and verification tools. So then I will get into, and I plan to touch this pretty quickly actually. I'm thinking of 2-3 videos on RTL, maybe 2-3 videos here, just to enable you to understand the basics of it. I don't plan to cover in detail like 20 videos or something. Maybe separately later on I can do more depth, but I really want to touch into physical design pretty soon. So I'll do quickly through these two topics and we'll touch into physical design. Goal of physical design is eventually generate a database called GDS, which we send to fab for their fabrication. So that's the high level plan for the next couple of months or so that I am thinking of. Let's see how much time I spend on physical design. So I'll take some sample circuits which have some simple combinational and sequential, and we look into different implementation stages and verification stages of physical design. I definitely, once I complete this, I plan to go back a little bit and take on a higher level picture and um, understand or teach or computer architecture. Very important that you understand how computation is performed right now. And every major disruptive technology that we have seen, there is a different architecture behind that. Like look into all the AI. NVIDIA is so successful there because the architecture they have is right for that field. When mobile came, tablets came, Intel architecture wasn't right for that. So we have seen ARM based architecture. And then previously we had PC where Intel and then servers where Intel and AMD and all that were very successful. So every major technology computational change comes with a core change in the computer architecture. So it's good to understand what are the differences between different architectures, and I will cover MIPS and RISC 5. What is the microarchitecture? What is their instruction set? What kind of different instruction they support? And once we know certain instruction, how we implement those instruction using the digital design techniques that we learn. And that thing is called microarchitecture. So this is more on how you can have a one microarchitecture you can really implement in a different way. That's called a different microarchitecture. I definitely want to touch on FPGA prototyping. I mean, SystemVerilog I will cover anyway. Then learning some of the tools and how we dump we configure FPGA with different hardware written in RTL. That we will do some examples, some maybe real time using real time prototypes or FPGA boards for that. Analog IC design, this is something in the industry I have not done, but my master was on analog IC design. I think analog IC design is a small portion of overall chip or die you have, but some of the concepts involved are very important. And I think I might give an introductory course on the analog IC design, and the final test chip that I want to design and fabricate and then validate that will have some analog components, so it will be a good revision for myself, and as I'm learning or revising my stuff I will create videos on that too. So that is my overall goal. Let's see how, if there are further changes in the next couple of months on this goal. It will take a while, but I'm super excited on completing it entirely. And I'm myself learning or revising a lot of things on it. And I really hope that others through my videos on YouTube will learn a lot. So thank you so much. And if you have any suggestion for any of that, or if I miss something important that you want me to cover, you're always welcome to text me on LinkedIn or send me an email. Thank you so much. Bye.